So Greg, how did you ever get the idea of looking at parts of the genome that are not expressed to have an influence on disease?
Well, some of that is just because I'm contrarian and everybody else was studying that stuff. Part of it was I read a paper that had posited that those regions would be important, but with very little strong evidence. And part of it, I was very fortunate to have some really bright graduate students who thought this would be fun to work on. And so we started working on finding evidence that these non-coding regions could exert significant influence on human health. And
you started off in the library, I understand.
Started off in the library, looking at a bunch of isolated studies. And it was interesting as we began to put the pieces together, it became clear that this is actually quite a common phenomenon. And what really capped it for us was reaching out to some of the people who had done these studies and describing what we had found. And almost to a person, they said, I thought we were the only one who found something like this.
Really? So they all thought it was really odd.
Quite odd. It wasn't the paradigm.
In fact, it's everywhere.
In fact, it's everywhere.
So this is a classic example, isn't it, of everybody's thinking in a certain way.
Right.
And it's not right.
It's not right.
What was the old paradigm? What's the new paradigm?
The old paradigm was the way you get sick is a gene breaks. It's not making
And it can't make the right protein.
Can't make the right protein. The protein's maybe doing something a little off. And that's how we get disease. And while that certainly happens, and there are many, many cases, what we weren't really thinking about is the fact that if we produced that gene at the wrong time, or too much of it or too little of it, or failed to produce it under the right circumstances, that could also lead to disease. And so that just wasn't widely recognized. Now, in retrospect, it seems fairly straightforward.
So can the environment you live in influence your gene expression?
Absolutely.
What are examples of that? Like living in the cold and shivering a lot? Does that change things?
Well, absolutely. I mean, you even change gene expression when you go to sleep and right after a meal, or if you've got the flu. So not all genes change their expression, but the ones that are responding in a sense, that are mounting your either a response to a pathogen or adapting to cold or
how about sunshine? When our skin turns a darker shade because of sun exposure, tanning,
Right.
Does that involve this kind of process?
Absolutely. We change gene expression, produce more melanins. It's a really useful process because if we're getting a lot of sun exposure, we're also getting a risk of developing skin cancer.
Right.
And so we produce essentially a natural suntan lotion.
Right. So a lot of people imagine, they think evolution fixed things, it's
Right.
genetic, therefore nothing can be done about it.
Right.
But what you're saying is that natural selection shapes all kinds of systems that adjust our body to circumstances.
Right. Indeed, sometimes the flexibility itself is the advantage, and hardwiring a certain condition basically locks you in. Doesn't.
So what are some examples of things where the flexibility gives you an advantage?
Well, certainly the immune system's a great one. You don't want to be producing all the compounds you use to fight diseases all the time. Partly it would just be an energy drain, but also partly because some of them make you feel bad.
And they damage your cells.
They damage your cells, and it's a trade-off. So you want to produce them only when you really need them. It's like you don't want the fireman blowing water at your house out of a hose unless your
Right.
house is on fire.
Right.
But at that point, you really want it, So
Right. Right.
yeah.